Hi, everyone. So I wanted to do some lectures to talk about quantitative results. Now, in understanding quantitative results, there's really three things that I'm going to focus in on here. The first is the levels of measurement, and this seems like it's definitional and it might not be as exciting to you as some other things, but it's actually really the basis of statistics. In order to really understand what information means in a study, you actually need to understand what the data is really saying and what types of information it's generated given the type of question it is. Then we're going to move on and talk a little bit about descriptive data analysis. And again, descriptive data is really talking about what does the information actually look like. And you're describing, a phenomena or some sort of traits or how a health condition is experienced or how common it is, for example. And then we have inferential data analysis. Inferential data analysis is really where you're taking data and you're applying it to understand a larger population that it's being generalized to, or you're using it in a way that you're actually testing hypotheses. So that's what we're going to be doing in these lectures, and I'm going to do it in 3 separate lectures. All right, so first off, levels of measurement. So I'm going to start off by just talking about some different types of data that you will see in these studies. And the first is the terms for dichotomous or binary data, which is really present or absent, yes or no, either or type things. So example, that would be, are you qualified for Medicaid? Yes or no, right? Then you have discrete data. Discrete data is data where there's a limited number of values. So you can have a certain number of children. Like, it doesn't make sense to say I have 3.5 children. Like that, it doesn't make sense in this context. You have 1, 2, 3, or 4 children, right? There's also things that are continuous values. So in that case, it's anything where it could be measured in a wide range of different ways. So you could measure height in meters, you could measure height in centimeters, you could measure height in millimeters, or you could measure in inches. It's a flexible value that you could use different ways to study, and you could do it in a more refined or more or less precise measure. Other types of terminology around data that we'll be using is ungrouped data versus group data. So ungrouped data is just the non-arranged measures, just the information as it comes up. So let's say you're talking about people who are who are present in a nursery, okay? So you might have a 1-year-old, a 2-year-old, a 5-year-old, a 3-year-old, a 19-year-old, 13-year-old, etc. If that's ungrouped, you just have those essential raw numbers right there. Group data is when you sort of say, okay, I'm curious about how many people fall into this range, all right? So you might say, okay, how many people are between the ages of 1 and 10? How many people are between the ages of 11 and 20? How many people are between the ages of 21 and 30? And you sort of count them up and you give a number. Now, when you do that, sometimes it's easier to do that type of thing. But you do lose some precision once you start doing that. Now, this approach is actually really useful for certain types of things. So, for example, if I'm asking somebody about their income, you could ask them, well, how much did you pay in income taxes last year? And they will say, I'm not going to tell you, right? Because that's private information. So what you do instead is you say, was it between 0 and 30,000? Was it between, X and X, that sort of thing. And when you put in these sort of intervals, people are typically more likely to answer some of these more sensitive questions. It's also often easier to gather that type of data. Okay, so levels of measurement. As I mentioned earlier, levels of measurement are essential to really understanding the types of statistics that you can do. You can only use certain types of statistical tests and analyses for certain types of data. So one thing as we look at the next slide that you should know is that the higher the level of data, the greater flexibility you have in terms of using different types of statistical approaches. And this is because you can always take this higher level of data and make it less precise. bring it down to a lower level of data. However, the opposite is not true. You cannot go from more basic data to more complex and detailed data. So let me just talk about what these levels are so that makes a little bit more sense. All right. So these levels of measurement are listed from the weaker data, the less precise data, up to the stronger data, the more precise data. So the nominal data is sort of the basic level of data, and that is really typically in binary data or unordered data. All right. So things like, do you have a RN? Well, yes or no. That would be nominal data. Or what is your hair color? Well, black, brown, red, purple, whatever it happens to be. It's just information. How many people have X, Y, or Z hair color. Now, what's important here is that there's no ranking to the hair color, right? Does red hair go before black hair, or does it go before green hair or brown hair? There's no sense in which one is higher than the other. Okay. Then the next level is ordinal data, and this is where the data itself has relative ranks, but the intervals themselves are not necessarily equal between the different rankings. So an example of this is socioeconomic brackets. So very often when we're doing this, we're measuring this, we say something like 0 to 30,000, 30,000 to 75,000, 75,000 to 150,000, and then 150,000 or above. And the reason that I use that example is that these intervals are not equal in size. So 0 to 30,000 covers less of a range than 75,000 to 150,000. And if you talk about 150,000 above, that could be anything, right? So there is a ranking. You could say that people who make 75 to 150,000 are making more money than people who are making 0 to 30,000. But you don't really know the levels in terms of, say you assign 1 to 0 to 30,000, 2 to 30,000, 50,000, and 3 to 50,000 to 75,000. Those numbers are not representing equal size categories. All right. So then you have interval data. So interval data is where you sort of have equal intervals. So an example of this would be temperature. All right. So as you're going up in temperature, you have distinct intervals that are equal in size, right? The thing to note about interval data is that the zero is arbitrary. So if I say it's 0 degrees Fahrenheit out, that doesn't mean that there's no heat, there's no temperature, right? Because you can go into negative numbers for that, right? But it does have that equal interval size. All right, so then we have ratio data. Ratio data is actually pretty similar to interval data, except so it has the same equal intervals, but it also has a logical absolute zero to it. So an example of this would be height, for example. You can be 6 feet tall, but you can, in theory, that goes down to 0, which is essentially no height, so an absolute absence of a thing. Or heart rate, you can go down to a 0 heart rate and you're dead. So there is sort of this absolute zero in those cases. All right, again, what you can do is you can always take those higher levels of data and turn them into more simple data. So for example, for height, you could say, Mary is 5'8", and Siobhan is 5'10", and Robert is 5'11", right? Or you could say, all right, how many people are above 5'8", and how many people are 5'8" or below, right? And then you've turned what is this ratio data into nominal data, because now you're essentially having yes/no data. Are they above 5'8" or not, right? So that's the idea there, that you can turn more complex data into more simple data. However, you can't, if you collect data as being, is this person 5'8" or above, or not, then you can't turn that in. You can't reverse engineer that to say, well, Mary is 5'8", right? You can't go and actually get the numbers from that more simple data that you started with. All right. So here's a few examples of this, and this is just a chance to test your knowledge. So I'm going to put these up, and then why don't you just pause the video for a second and look at these and think about how you would categorize them in these different levels of measurement. So I'm going to give you a few seconds, and you can pause it, and then I'll just tell you what the answers are. Okay, so I'm assuming you've had some time to think about it, and you've tried to figure out what was what. So oral language skills. So in that case, when it's a ranking by the teacher, you have a low, medium, and high. All right. Well, in this case, the intervals, it's kind of hard to assess whether low is equal to medium or high. These intervals might be substantially different. It's also kind of a bit of a fuzzy ranking, right? So I would typically describe this as being ordinal data. Now, when you have these rankings, sometimes once you get past a certain number of rankings, sometimes if you think that they're reasonably accurate in terms of measuring equal intervals, sometimes you'll start treating it as interval data. Usually, as a rule of thumb, if it's 4 categories or less, usually it's almost always treated as ordinal data. You usually need at least 5 points on the scale in order for it to be treated as interval. Now, this is actually a controversy in the field, and some people use different types of things, but I would say that that's a good rule of thumb for thinking about this. All right, the country you were born in, that would be nominal data. There's no real ranking to that, right? So does Bolivia go before Canada? Well, maybe alphabetically, but not in any sort of real meaningful conceptual sense. So it's just factual, were you born in Canada or not? Were you born in Bolivia or not, right? All right, marital status of participants in your study. Again, that would be nominal data, so yes or no data. Are you married or are you not married? Scores on the multiple choice test. This could be seen as being ratio data in the sense that, say you had a 100-point test and you could get from 0, which in theory would be measuring 0 knowledge, up to 100, which would be measuring all the knowledge, right? Now, there's some, you could criticize this and you could say, well, does 0 really mean that people have no knowledge? Well, maybe not, right? Or does a test actually measure equal intervals? Well, people you have different questions on the test, and they have different difficulties. So if someone misses a really hard question and another person misses an easy question, does that actually mean the same thing in terms of actual knowledge? So you could quibble about this, but very often it'd be treated as ratio data. Weight of subjects in both control and treatment groups, I would say that would be ratio data because weight can go down to a conceptual 0. Number of minutes of overtime for nurses, again, I would describe that as ratio data. Ages of patients who are 41 to 50, 51 to 60, 61 to 70, and over 70, that would be, even though it looks like they're equal intervals there, if you look at that top category, then it's actually nominal. It's actually ordinal because that category could be as big as possible, and so we're having different sized intervals. The last category here, where you have a range of different ages, and you're stipulating that no participants were outside of these ranges, you could actually describe that as being ratio data because there is actually a conceptual 0 in terms of age, and also all the intervals were equal, even though the ranges covered multiple years. And again, for continuous data, you can group things into any size of bins that you want them to be, right? But you have to make sure that those intervals are the same in order for them to be interval ratio data. All right, so that's just the basics of levels of measurement. I know it's not terribly exciting, but at this point, but it is actually essential to knowing how to analyze data using a range of different quantitative statistics. All right, I will continue on to talk a little bit about descriptive statistics in the next lecture.